Right, today, most important thing today, radians. Radians are angles. The radians are angles that equal the arc length. Mr. Massey likes to say that aliens use radians, but they don't use degrees. Degrees are things that we invented. Okay? Aliens use radians because it's a universal length. But degrees are not used in outer space. If we had aliens, and if we could meet them, they wouldn't use degrees. That's something we invented, okay? We invented degrees. So, if I take a look, and I want to draw a circle, and let's take a look at some things we already know, okay? So let's take a look at a circle. Draw my circle in. And in this circle, 0 degrees, 90 degrees, 180 degrees, 270 degrees, and back to 360 degrees, right? Circle. But circles were invented by people, humans. But I want to know something about the arc length. So if the radius is 1, okay? So the radius is 1. Then, I'm going to put this in at a different color so you can see it. Oh, where's my, okay. So then, if I went around the circle, this arc length is pi. And the reason I know the arc length is pi is because the circumference of the circle is pi, 2 pi r, circumference of a circle. So from here to here is pi, and all the way around is 2 pi. I need a better pen. Where's my better pen? Here we go. Okay. I'm just going to go pi and 2 pi. Okay. From here to here is, that's pi, this is pi halves, and this is 3 pi halves. Okay. We're going to put this on a circle tomorrow. Okay, what does that mean? That means that I have an angle. Of 180 degrees, which is also equal to pi radians. They're both angles. They're both the same angle. 180 degrees is the same angle. You should write this down. The same angle. 180 degrees and pi. Okay? But the arc length is also pi. The arc length is also 3.14, so the arc length and the angle are the same. Okay? We also have an angle. It's an angle of 360 degrees, which equals 2 pi radians. Okay? So I know 1 radian up here. 1 radian is equal to an arc length of 1 with a radius of 1. So this angle right there it's an angle, and that's 1 radian. Okay, so it's a little confusing. Kai, it takes a while to really get the hang of what radians are. You agree with that? Okay, but so if you're totally lost, hang in there. But more importantly, it's an angle. Radians are angles, okay? Well, we're still kind of stuck in degrees, so let's go ahead and see what we can do about this one. 400 degrees. Well, I'm going to try and put it so I can put the circle in the middle of the paper, right? How many degrees are in a circle? So this 400 degrees, everybody watch. All eyes here. we're going to go 360 plus 40 more. Does that make sense? 400, 360 plus 400. So let's go ahead and try to do this, okay? So this is the same thing as 360 plus 40. So I'm going to draw it like this. So I showed the whole spin. 360 plus 40. And there's my angle. In standard position. So it's like rotating the tire all the way around, okay? Negative 100 degrees. Would be going backwards. I know this is 0, negative 90. I'm going backwards. So negative 100 degrees would be right about there. Or, it's the same thing as 260 degrees. How did I get the 260? Come on, thinkers. Come on, smart kids. Why are these two angles the same? Come on, why are these two angles the same? Come on, smart kids. Why are these two angles the same? Yeah, it's just backwards the other one, right? Agree? Negative 100 or 260 gives me the same spot. You guys agree with that? Same spot, right? Okay. Okay, so then 15 pi fourths. Wow, what the heck? That's a radian. So what the heck is that? Well, we're going to have to convert this. So if we turn the paper over to example 5, we have a formula. Okay, I'm going to circle that formula. Okay, we have a formula. So if we've got a radian, it'd be easier if it was in degrees, right? So I got a formula. I'm going to write that over here. I'm going to say my degree is equal to, my formula says 180 over pi times my radian. Okay, there's my formula from on the other side. Okay, so this is a radian. That's a radian. That's an angle. Let's see if we can make it easier for us by making it a degree. So I have a little formula. So how does this formula work? I'm going to take this number, put it there. Okay, so I'm going to do that. I'm going to go, my degree is equal to 180 over pi times my 15 pi over 4. So I like degrees. I'm comfortable with degrees. You guys agree? Radians are brand new, man. I really, radians right now are hurting my head. So this is a radian angle. Let's change it to degrees. Okay, so here's my formula. I take 15 pi fourths to the right there, okay? Okay, let's see. I can cancel the pi's, right? Good. Grab your calculator. Cancel the pi's. Right? Cancel the pi's. Grab your calculator. What am I going to do? I'm going to cancel the pi's. Then what am I going to do? Yes, Jacob. Yes, Oops, I canceled the wrong thing. Sorry. Say it, Jacob. You told me. We're going to 180, right? Times 15 divided by 4, right? About 625 degrees. I can do that. Okay. So I'm going to go 360, right? Okay, see how I've got my 625 minus 360, and I get a 265, so I'm going to keep going around. 90, 180, 270, right? This is probably right about there, huh? Okay with that? So we had a radian, and it scared me, but I changed it to a degree, and I was able to do it, okay? Okay, example 2, how am I doing? So, all right, so if I drew a 60-degree angle, right? It's about there. It doesn't have to be perfect. It says I want a positive and a negative angle. All right, so let's spin it all the way around. It's like taking a tire and spinning it all the way around, okay? What would that degree be? Spun it around. How many degrees did I spin it? How many degrees did I spin it? I took that tire and spin it all the way around. How many degrees did I spin it? 360, right? So if I add 360 to this, I'd have a, let's see, what is that, a 420 degree angle. These two angles are the same. One, they're in the same position, right? Or I could spin it backwards. So all three of these are the same spot, but just spun, okay? This is like I walk up to my car, and I see a tire, I see a nail in my tire, bummer. So I rotate my tire 360 degrees to make sure I don't see another nail, right? Or I spin it backwards to make sure I don't have another tire. All three angles are in the same spot, okay? So what about B? Well, I already have negative 120 degrees. Let's see, that's right about, that's negative 90, right? 0, negative 90, so it's about there, right? So I could take my tire and I could spin it 360, right? Which would give me a 240 degree angle, right? Or I could spin it backwards even more, right? I could take my negative 120, I could spin it backwards even more and get a negative 480 degrees. There, there, and there. All three of those are in the same spot. I get up, same thing, look at my tire, I'm like, dang it, I got it flat, right? The nail's right there. So I can spin it backwards and look at it that way. Or I can spin it even more backwards and put it there, okay? Put the nails in the same spot and just spin it to make sure there's no more nails. Okay, now, 2/3, that's a radian, right? That's a radian. So I'm going to use my formula. Degree equals 180 over pi times my radian. Let's change it to degrees, because I'm not familiar with radians. Radians really bother me right now. They don't even look like angles. You guys agree with that? So let's change that radian into a degree, okay? So, all right. A degree is equal to 180 over pi, and I'm going to put this right there. Okay, what am I going to do? Cancel the pies, and then? Yep, exactly. I'm just going to go 180, oops, yep, times 2 divided by 3, and I get about 120 degrees. So, there's 90, right? 90 is there. So 120 might be about there. You guys okay with that? 120 is right about there. Okay, so how would I get another angle in the same spot? Same spot. How do I get it? Same spot, give me another angle. How would I do it? Same spot. Yeah, turn it backwards. Let's turn it backwards. Okay, Jacob, let's turn it backwards. So to turn it backwards, let's subtract 360, right? That give me a negative 240 degree angle. That'd be like going like that, right? Or I could just spin it forwards and add another 360, right? 120 plus 360 makes the 480 degrees. Okay, let me highlight all my answers. I got that answer, I got that answer, and that answer. And I even have that answer. All four of these are the same angle. They're in the same spot. Same spot, okay? All right? 2/3 is exactly at 120 degrees. You get that? It is. It's a weird angle, but it's an angle. But it could also be at negative 240 because I spin it backwards, or 480 because I spin it forward on rotation. Okay? Not bad. Not too hard. Okay, let's turn the page. Now, reference angle. Reference angles are super important because, first of all, if we want to do trigonometry, which we do someday, right? This is not going to make it. You can't have a 340 degree angle in a right triangle, can you? And if we want to use right triangle trig, which is easy, we don't want 160 degrees because it wouldn't work in a right triangle. So here's how it works, okay? It's actually really easy. Okay, 160 degrees is about there. Okay, it's not perfect, but you know, you cut through it. You guys agree about right about there? If that's 90, that's 180. What's this angle? What's this angle? 20. You guys agree at 20? That's the reference angle because I can make a right triangle. So the reference angle is 20 degrees. Check out 340. That's 360. That's 270, right? So if I went all the way on 340 degrees, it's right there. That's my reference angle. My reference angle is an angle that makes the right triangle. What's that angle? 20 degrees again, right? You guys see that's 20 degrees again? I mean, if it's 340 degrees to here, that's got to be 20 again, right? Now 5 pi 6. 5 pi 6. Okay, so I got to do my conversion, okay? So I'm going to take my 180 over pi times 5 pi 6. I got to convert it because I don't like radians. I'm not used to them yet. So I'm going to change this angle into degrees, okay? I don't like radians. Let me just change, okay? So cancel the pi's, and then what? Multiply, right? Okay, so I'm going to go 180 times 5 divided by 6, and I get an answer of 150 degrees, okay? Let me draw a picture. I know 90, 180, so 150 is right about there. Yeah, Jacob, you already got it. 150. This is my angle there. Jacob said it. 30 degrees. You got it. You understand reference angles. And the reason they're so important is because eventually we're going to want to use that because it's an angle, right? We're going to eventually want to use this. We're going to make an angle that's an angle we can use, right? Okay. Now, the next one you already know. We don't know how to do this, except it's the other way around. So 100 degrees is an angle. But there's a radian angle that's the same. So here's our formula. It's the other formula, okay? So let's see how this works. Oh, put times. Yeah, there's my degree. Okay, so how do we do it? So radian equals 100 degrees is a degree, but there's also a radian angle that's the same. Put the 100 right there. I go 100 over 180 pi. Now, before we do too much, did you notice all of these weird things have pi's in them, right? They all have pi's in them. All these radians have pi's in them, right? So I'm just going to reduce this and make this 5/9. You okay with reducing? Can you see 5/9? Yeah. 5/9 pi. We'll use the decimal someday, but for not right now. So if I reduce, I'm going to get 10 over 180, which is 5 pi 9ths. Same angle, different name. Same angle, different name, okay? All right, negative 300 degrees. All right, same thing. We're going to take and put the negative 300 in for there. We're going to go the radian is equal to negative 300 over 180 pi. So I'm just using my formula, that's all, right? Okay, that'll reduce to 30/18. If I divide both by 6, I'll get negative 5 6/3, okay? I just reduced, okay? Okay, so these two angles are the same. They're the same angle. Same angle. They really are. This is degrees, which we like. This is also an angle. This is also an angle. Okay? All right, now, we're almost done. Last but not least. Well, not quite last. Use our formula. We've done this. We go 180 over pi times 5 pi 6, all right? We just plug this into there, okay? Now what do? Cancel the pi's, and then what? Yeah, 180 times 5 divided by 6. So 150 degrees. And 5 pi 6 are the same angle. Okay, now 1 radian, kind of told you what it is already. 1 radian is about 57 degrees, but let's double check it. Let's use the formula. I'm going to go 180 over pi times 1. Now you can't cancel a pi, can you? So I'm just going to have to go 180 times 1 divided by pi at about 57.3 degrees. So I'm going to turn my paper over, and I want to put right here that this angle is about 57.3 degrees. Okay, 1 radian is about 57.3 degrees. Okay, all right, almost done. Now, where is this stuff used? Well, stuff's used in arc length and area. Okay, I think I'm going to wait on this until tomorrow because it's not in your homework, but I'm going to wait on this till tomorrow because I think your brains are overloaded. Would you agree? Okay, so we still have time to get some stuff done. So I'm going to give you your homework.